Hello again, everyone. So, this is Arthur, and this is my week 4 presentation. And I have been tasked to do problem 2.6.5 from the textbook, which is this problem right here. So, this problem states that it may seem plausible that we can verify a tautology by making a truth table with the sentence undenied, and then concluding that the sentence is a tautology if and only if every pass in the finish tree is open. And I have been tasked to try this out on sentences A. This sentence right here, the disjunction of A, not A, and then the conjunction of, and then the conjunction between A and negative and not A, and then I have to prove that. Then I have to answer this question. If this test always give incorrect answers. So first of all, we will start with the problem, with the statement of the problem. So it says here that we can have a different solution, which is because on problem 2.6.4 we are given a different we are given a test to verify if a sentence is a tautology, which we will show here. Um, um, so this is the textbook, and here in here it says that to see whether or not a sentence is a tautology, we will start day 3 with its denial and proceed as if you were testing an argument for validity. So it just basically says here that you start with the sentence itself in its denial, and then you just work your way down. And then if the tree closes, then it is a tautology. If not, then it's not. And we will go, and this knowledge right here is builds up to 2.6.5. So we will start with the problem right now. Let me go back to my screen first. There we go. So first, since it is a biconditional statement, we have two cases that we should verify. So first, if every path in the proposed solution is open, then the sentence is a tautology. And if the given sentence is a tautology, then every path in the proposed solution is open. So we will start with letter A here, which is sentence A. So for this sentence, we can first make its truth tree without making it with the sentence undenied. And this is the resulting truth tree. Very simple. It will read. And we can see that it kind of satisfies the first conditional since every path in the proposed solution is open. However, A itself is not a tautology. Why? Since A itself can be either true or false. Meaning, meaning even though that the proposed solution is the path, the truth tree is open in this solution, the sentence, however, is not a tautology. Meaning in our conditional one, where every path in the proposed solution is open, which is true, and then the sentence is a tautology, which is false. The conditional is therefore false since that is a counterexample. That conditional will result in a false statement. Hence, the solution provided us a wrong answer. Now for letter B, which is this sentence right here. So since this is a very messy one, we should first verify if this one is a tautology. So first we will make a truth tree where we start with the sentence denied, which is this one. And so this is our premise. And then for a group of disjunctions to be false, then every statement in it should be false. So first we negate this one, which is not A. Then we will negate this one. And since this will result in a So since this is our original statement, and then we negated it, that which is a double denial, this one will be positive, which is basically equal to A. And then we will negate this equation, this statement, the conjunction between A and not A. However, since our decomposed statements already, negative A and A already contradicts each other, then that means the path itself is closed, even if we do not have to decompose this statement. So what does that mean? As per problem 2.6.4, the solution given to us on whether a sentence is a tautology, the denial of the statement is false. Therefore, our given statement here is a tautology, which is based on 2.6.4. And so since we already have a tautology, then we will just use the given solution to us. So we will start with the statement which is undenied, and then we have to make sure that every path in this truth table will be open. So first we will start with this one, which is the conjunction between these three statements, A, negative, no, not A, and then the conjunction between A and not A. So that is our premise. And then we will decompose that statement. And for this premise to be true, then only then we have three cases where this disjunction should be true. A should be true, not A should be true, and this statement should be true. So since this is our only premise in the truth tree, we'll leave these two statements open since we have no other statements to add to it. And so we are left with this conjunction, which is the result for decomposing this statement. And now we have this statement, so we will have to decompose this one. And for this conjunction to be true, then then both then both the then both A and not A should be true, which we will go down here. And then we will encounter a problem here. A and not A will contradict with each other. Then that means that this path here will close. So what does this mean? As we have proven earlier that this statement is a tautology, since we have proven that its denial will result in a closed tree. In this test, however, we start with the undenied statement. There is one closed path, as it has been said earlier that that the sentence is a tautology if and every path in the finished tree is open. In here we have one open, we have one closed tree. So if we are going to use this test, then we are to conclude that the sentence is not a tautology, even though it is. So our solution here gave us an incorrect answer. It is telling us that it is not that the sentence here is not a tautology, even though it is. So if we are to use this solution, we will conclude that the sentence itself is not a tautology, even though it is one, as stated here. And as I've said earlier, it gave us a wrong answer. So we are done with letter B. And so we are down to the last problem. Does this bogus test always give incorrect answers? And there are two ways that we can prove this. We either prove that in every statement that we find it is always incorrect, or we can provide it a tautology that will gives us a correct answer. And since the former one is very hard to prove, we will go for the latter. So first, we will try this sentence here, which is A biconditional, which is the biconditional between A and itself. Now, this given sentence is true if both sides are equal in truth value, and since A is always equal in truth value with itself, then the sentence will always be true. Therefore, this statement here is a tautology. And now, what if we will try this tautology with a proposed solution, which is we will start with it undenied and then make sure that its paths are always open. In every path, it is open. So first, we will decompose this one, and since as per the rules of inference, let's go back to the rules of inference, which is in the textbook. This one. So so both should be true or both should be false. Hmm. And we can and as we can see here, this is our A, this is our first one, and this is our second one, which is down here. And they should be both true or they should be both false. And as for the second path, it is this will result for the second path. As the result for decomposing this to this statement. And look what we have here. We have a tree here with an open path. Since the sentence itself is a tautology and the resulting tree has every path open, the test gave a correct answer, even though the other two did not give a correct one for sentence A and then this sentence right here. So what does that mean? It means that this test O does not always give incorrect answers. It can give correct answers in some cases, but it might be rare. So we are better off starting with the statement in denial and then working our way down to prove it if the given statement is a tautology. And yes, so that concludes my presentation. I hope you I hope I was clear, and yep.